That we're going to do today, we're going to find 1A, what is the percent by mass of copper in Cu2S. B, what is the empirical formula of ore number 2? C, if a sample of ore number 3 contains 11 grams of iron, how many grams of sulfur does it contain? And D, if 3.84 grams of O2 are consumed in the process, how many grams of Cu are produced by using this equation? And right here we have our chart that gives us all the information that we're going to be using throughout this process. Alright, so the first question of the day is, what is the percent by mass of copper in Cu2S? So the percent by mass means a mass percentage that expresses the concentration of a component in a mixture, element, or compound. So we're going to find the percent mass of Cu2S, and that is a compound. So we're going to list all of our givens. So we are given the compound Cu2S, and the weights of both Cu and S. Cu weighs 63.5 grams, and sulfur weighs 32 grams. And then our unknown is the percent mass of the Cu. So first, we're gonna find the molar mass of Cu2S. So we gotta take 63.5 times 2 because we have 2 Cu2s, and that will give us 127 grams. And then we have 1 sulfur, so we'll just add 32 grams to the 127. And we'll get a total of 159 grams for Cu2S as the molar mass. Now, once you find the complete molar mass of the compound, you're going to take each one over the entirety weight to find the percent of each in the compound. So we have 2 Cu2, so we have 127 grams of copper in the compound, and then over the total, which is 159 grams. And then that will give us, let me put in my calculations real fast, 0.78, sorry, I read that wrong, 0.98 grams, and then we'll multiply that by 100 to give us a percentage, and so 79.8% of copper is in Cu2S.
Yeah.
Alright, so with the answers from our last problem, we were able to fill in our table some more, and we had the 79.8 grams of copper, and then to find the grams of sulfur, we just subtracted that from 100 because they all added up to 100%, so we got 20.2 grams. So our next question is, what is the empirical formula of ore number 2? So an empirical formula is a chemical formula showing the simplest ratio of elements in a compound rather than the total number of atoms in a molecule. So for example, Cu2S is an empirical formula for the percentages of the copper and sulfur that are in this compound. So when we find the empirical formula for ore number 2, first we're going to list all the percentages of the elements that are in there. So we have 34.6% of copper in it. We have 34.9% of sulfur and 30.5% of iron in this compound. Now, if we add all these up together, they will give us a good total of 100%. So that tells us that in this compound we have 34.6 grams of Cu, 34.9 grams of sulfur, and 30.5 grams of iron. Now, since we have the total number of grams of each, we're going to take each one and divide them by their total weight, by the weight of what they weigh on the periodic table. So, Cu is 63.5 grams, sulfur is 32.0 grams, and iron is 55.8 grams. So we're going to take 34.6 over 63.5, and that will give us, let me put in my calculation, 0.54, and this is for Cu. And for S, we will put 34.9 grams over 32, and that gives us 1. And then for iron, we will have 30.5 grams over 55.8, and that will give us 0.54. And then you're going to want to divide each of them by the smallest number. So 0.54 is the smallest, so we're going to divide each by that. That's going to give us 1. That's 1, and this one is 1.85. And then we'll just round that off to 2. So once you have all those, you're able to find your empirical formula, which will be Cu S2Fe. All right, so from our last problem, we were able to fill in our chart some more, and we found the empirical formula of ore number 2, and that was CuS2Fe. Once again, if you need to write that down. And so for our next problem, we have, if a sample of ore number 3 was 11 grams of iron, how many grams of sulfur does it contain? Now first, we're going to list our givens and our unknowns. So, and I already have that down for you. In our givens, we're 11.0 grams of iron, which was in the problem given. And then if we refer back to the table up here, we see that we have 55.6 percent of copper, 28.1% of sulfur, and 16.3% of iron. Now this problem is going to be pretty similar to the last one. So 55.6% of Cu, 28.1% of sulfur, and 16.3% of iron. Now if we added all those together, we would get a total of 100%. So once again, that means we have 55.6 grams of copper, 28.1 grams of sulfur, and 16.3 grams of iron. So we're going to take each one and put them over the total mass, their molar mass. This one is 63.5, sulfur is 32, and iron is 55.8. So we have 55.6 over 63.5, 28.1 over 32, and 16.3 over 55.8. Now, the first one will give us 0.87. The second will give us, sorry guys, I'm putting in my calculations, 0.87. And then this one will give us 0.29. So like last time, we're going to divide by the smallest number, and 0.29 will be our smallest. So we'll take everything and divide it by 0.29. This will give us 1. And then both of these, since they are similar, they will give us 3. So we find out that our empirical formula for this compound is Cu3S3F. Now, once we have that, we're going to find the total amount of grams of sulfur in this compound. So, once again, we have 11 grams, so we're going to start with that. We have 11.0 grams of iron. And then we have, for 1 iron, it is 55.8 grams. And that is 1 mole of iron. Oh, sorry guys, let me make some more space for you in this problem. Let's get rid of some stuff. Let's make more room. Alright, so, sorry about that guys, let's start this over. So, 11.0 grams of iron was given to us in our problem. And then so, 55.8 0.8 grams of iron equals 1 mole of iron. And then we're going to continually refer back to our empirical formula down here. So, and we're going to want to transition this over. So 1 mole of iron, because we only have 1 mole of iron down here, equals 3 moles of sulfur. And then 1 mole of sulfur weighs 32 grams. Now, when we multiply the whole top row and then divide it by the bottom, we will get 18.9. So the total amount of grams in this compound down here is 18.9 grams of sulfur. All right, so for the last problem of the day, we have Cu can be extracted from Cu2S by this following equation. So, if 3.84 grams of O2 are consumed in the process, how many grams of Cu are produced? So our given is 3.84 grams of O2, and our unknown is how many grams of Cu are produced. So we want to find the grams of Cu. So we're just going to set up our equation. We're going to start with the 3.84 grams of oxygen. Then, so 2 grams of O2 equals 32 grams, because 1 is 16, so 16 times 2 is 32. And that equals 1 mole of O2. And then if we look up at this equation up here, 3 moles of O2, well, 1 mole of O2 equals 3 moles of O2, and then 3 moles of O2 equals 6 moles of Cu. And then we're just going to find the grams of Cu. So 1 mole of Cu is how many grams? It is 63.5. Now, if we multiply the whole top row up here and divide it by the bottom, we will get, let me put in my calculations for you guys, 15.3. So the total number of copper produced in this problem and 3.84 grams of O2 is 15.3 grams.